Howdy, folks. Going on with section 8.5. This is 8.5 continued. Tonight we're talking about complex fractions. Guys, all a complex fraction is, let me tell you right now, it's just a fraction within a fraction. It's like the inception of fractions. Ladies and gentlemen, take a look at two simple examples of a complex fraction. I've got 2/3 divided by 5/3. Notice I got two baby fractions inside of this big fraction. All right? Take a look at this booger right here. I've got 1 over x plus 1 over 2 over x minus 1. I got baby fractions inside of bigger fractions, right? Ladies and gentlemen, complex fractions, no bueno, no bueno. You must always simplify. You must always simplify complex fractions into a single fraction. Okay? Now, there's several ways to do this. I think I've got a quick and easy way of doing it, right? Guys, I know that in this section previously, last night, we talked about getting LCDs. If you have good skills of getting an LCD, this is going to be real easy for you now. So take a look at what I'm going to do here. These are my steps. I'm going to make all the terms in the expression have the same lowest common denominator. What I mean by that is every small fraction, every baby fraction will have the same baby denominator. If I can do that, then I can cancel out all these baby denominators right here, right? By doing so, that'll create just one gigante fraction, right, from just your numerators, okay? Now, like always, once you get down to that single fraction, if you can simplify it, all right? So let's take a look at what I'm talking about. Here's example A, all right? In example A, I've got 2 over x minus 1, my first baby fraction, all over 4 over x minus 1 plus 1 over x. So I got 3 baby fractions inside of this big fraction, right? Well, let's take a look at this. To find an LCD, I know that if I can factor any of these baby denominators, I need to factor them. Does this first baby denominator factor? No. Does this baby denominator factor? No. Does this baby denominator factor? No. So I just create my LCD list from these already factored bottoms. I've got an x minus 1 from the first guy. I put it in the list. I see another x minus 1. Oh, he's already in the list. And then I see an x right here. He needs to go in the list. I hope that we can all see that my LCD is x minus 1 times x. Now all I'm going to do, I'm going to make each of these baby denominators have that LCD. What does this first baby denominator need? It needs an x. But if I give something to the bottom of a fraction, I give it to the top. What does this baby denominator need? An x. But if I give it to the bottom, I give it to the top. And what does this last baby denominator need? It needs an x minus 1. So if I give it to the bottom, I give it to the top. Now the fun begins. Since all the baby denominators match, notice they all have an x and an x minus 1 on the bottom. You get to cross them each out. So what am I left with? Well, on the top, I'm only left with a 2x. Everyone's got 2 x's left? On the bottom, I'm left with a 4x plus 1 times x minus 1. All right? Well, now, I know I can simplify that into 2x over 4x plus distributing the 1. Wouldn't that just be x minus 1? And then lastly, I get 2x over 5x minus 1. Now, the last thing, can I simplify this fraction? Well, no. Since this 5x is connected to this 1 with a subtraction sign, I can't cancel anything, so I'm done. Notice I'm left with just one simple fraction. All right? Let's try this again. Everybody take a look at example B. Ready? Let me blow this up. Oh, my God, that's hideous. All right, let's take a look at this. So, can I factor this first baby bottom? No. Can I factor this second baby bottom? Absolutely. Isn't that x plus 4x minus 4? And can I factor this last baby bottom? Yeah, I can factor out a 3x, x plus 4, correct? Let's make my LCD list. I see an x minus 4 from here. I put it in the list. I see an x plus 4 from here. I put it in the list. I already see an x minus 4. I already have an x minus 4 in the list. I don't need to repeat that. I see a 3x from here. I put it in the list. I see an x plus 4. Oh, he's already represented. I don't need to write it twice. Now that I've got my LCD, all I do is make the old baby bottoms become the new LCD. So what does this first baby bottom need? Well, he needs an x plus 4 and a 3x. What does this baby bottom need? He needs a 3x. Oh, I'm a bad boy. Oh, I'm a bad boy. I have to give what I give to the bottom, I give to the top, right? Oh, gosh. I'm sorry. I'm out of sorts. X plus 4, 3x. This baby bottom needs a 3x, so his top needs a 3x. This baby bottom needs an x minus 4, so x minus 4. Now I get to cancel out all the baby bottoms since they all match. In the top, I'm left with x plus 4 times 3x. And on the bottom, I'm left with 5 times 3x minus 2 times x minus 4. Distributing the top, I get 3x squared plus 12x. You know, I know what you're saying. I know what you're saying. Gosh, it's running into the top. Let me give myself some more space here. Let's see. That becomes 3x squared plus 12x. Don't judge me. All right. And then on the bottom, I get 15x minus 2x plus 8. Everybody got that? Combining like terms in the bottom, I get 3x squared plus 12x over 13x plus 8. Can I cancel anything from top and bottom? I don't think so. And that is your answer. Boom! Ha! What did I not do? I'm a bad boy, though. I'm a bad boy. Oh, I should have said my restrictions. What are my restrictions? Well, from the beginning problem, does it make sense that from the beginning of the problem, the x couldn't be 1 and 0? Right? And from the new baby bottom, and from the new bottom, x can't be 1/5. Does it make sense? Because notice that's a new bottom there, right? Remember, anytime we're doing this, we have to find all denominators restrictions, okay? Let's go to this one. On this example, what can x not be? X can't be 4, x can't be negative 4, and x can't be 0. Right? From this denominator, and this denominator, right? And from my final answer, x can't be negative 8 over 13. Come see how I got that? All right? Hey, I hope I didn't go too fast, but a lot of people have been saying, Mr. Cog, these screencasts, they take up my whole evening. I don't have time to go watch TV or whatever. Folks, see you tomorrow. Love you.